All right, let's get right into it. Welcome to this briefing. Look, if you're an IT engineer, a systems architect, or an exec trying to keep your company's AI initiatives actually running, you already know the absolute headache of system failures. Today, we're going to establish a standardized framework for troubleshooting and scaling these AI systems. We're looking at a really powerful mental model called CDMSMOLE. It's designed specifically to help your technical teams stop guessing and start diagnosing. Here's our roadmap for this explainer. We'll start with the AI troubleshooting chaos, then enter the CDMSMOLE framework, break down compute, data, and models, explore the upper stack layers, and finally actually diagnose some AI system outages.
Okay, part 1, the AI troubleshooting chaos. For decades now, the classic OSI model has served the networking and telecom worlds incredibly well, right? I mean, it gave everyone a shared standard language. If an engineer said, hey, this is a layer 2 problem, or we've got a layer 7 issue, literally everyone in the room instantly knew where to look, regardless of the vendor. But in modern AI, we have absolutely zero shared mapping. We've got training, inference, agents, memory, retrieval, user experience, all just mashed together into one giant black box.
And because we don't have that layered standard, we end up with these massive communication breakdowns. When an AI system degrades, just think about what happens in your war room. Your infrastructure team is talking about clusters and nodes, your machine learning team is going on about fine-tuning and loss curves, and your product team? They're just complaining about broken features and dropping conversion funnels. So you get these incident reports where 3 different teams describe the exact same system failure in 3 completely different languages. It's wildly inefficient, and it's bleeding your business of time and money.
Moving to part 2. Enter the CDMSMOLE framework. Enter CDMSMOLE. It is a unified, layered framework that stands for compute, data, models, serving, memory, orchestration, logic, and experience. It's a compact, pretty simple acronym that maps out the entire AI ecosystem. It basically allows you to walk through your system from the raw bare metal hardware all the way up to user adoption. Instead of just looking at AI as the model, this gives your whole org a structured way to reason about the entire stack.
Part 3. Compute, data, and models, the core engine.
First up is the C, the compute layer. You can think of this as the AI version of the OSI physical layer. We're talking about your GPUs, your CPUs, TPUs, VRAM limits, PCI bandwidth. Compute is your absolute physical foundation. I mean, if you're running your flagship model on an 8 GPU box but you're wiring it over a ridiculously slow network backbone, you're going to have a bad time. If your GPUs or your VRAM are starved, your system is going to be flaky, period, regardless of how, quote-unquote, intelligent the model sitting on top of it actually is.
Next is the D, the data layer. This is everything that flows into the system and dictates what it can actually learn. So ingest from apps, deduplication, stripping out PII for compliance, labeling. If someone asks you, why didn't the system know this, or what actually trained this model, they are asking a data layer question. Your data flows up and shapes the system's capabilities. Basically, garbage data guarantees your model is going to behave like garbage.
And that brings us to a massive takeaway from the source material. Optimizing this data layer is usually the largest single operational lever you can pull. If you take years of raw support tickets, clean them up, strip out the junk, and label the absolute best answers, you've just created a high-value data asset. That asset is a huge lever that practically guarantees operational success and a much higher ROI than just tweaking a model. Then we hit the M, the models layer. These are the learned brains of the system. We're talking base open source models, your proprietary fine-tunes, different variants you swap out. Maybe you use a heavy 7 billion parameter model for the really complex tasks and a snappy 3 billion parameter one for low latency jobs. But here's the critical dependency everyone forgets. Models are completely powerless without robust compute and data sitting underneath them. They only capture patterns based entirely on those 2 lower layers.
Part 4. The upper stack layers.
So that brings us to S, M, O, L, and E. These are the crucial layers where system behavior, your business policies, and actual humans meet the AI. Serving handles your real-time execution and batching. Memory manages session history and vector stores. Orchestration is your agent control and routing. Logic, that's your hard business rules and quotas. And experience is the UI and developer APIs. Let's break down why these dependencies matter so much. Look at how these rely on each other. Serving is your raw muscle. If you're tracking P95 latency or queries per second, you are dealing with the serving layer. You could have a massive, absolute genius of a model, but if your serving layer is weak, it ruins the whole thing. It's unusable.
On the flip side, the M is memory. This is how the system remembers interactions without just stuffing a giant prompt full of noise. Really good memory, like using vector stores to pull in exactly the right context, can make a tiny model punch way above its weight class. Moving up to the top 3. Orchestration decides exactly how to use that model. Should it call an API, pull a document, or just generate an answer? Logic is where your AI collides with the real world. It keeps you legally compliant. For instance, if an AI agent proposes a massive price change, logic is what ensures a human actually reviews it first. And finally, experience. That's the ultimate barrier to user adoption. You can have a flawlessly architected stack underneath, but if the UI is clunky or your APIs are poorly documented, your users are just going to walk away.
And finally, Part 5, Diagnosing AI System Outages. Right now, engineering teams are wasting countless hours on what we call the false diagnosis. When an app feels sluggish, everyone instantly blames the model itself, and they waste cycles trying to swap it out. When the AI starts hallucinating, they blame hardware limits. Or even worse, product managers file these totally ambiguous bug reports just titled AI issue. It's madness. And this is exactly the chaos that the CDMSMOLE framework eliminates.
Let's walk through one really clear example. Here is your CDMSMOLE diagnostic checklist for a latency spike. Instead of immediately defaulting to blaming the model, you move layer by layer. Step 1. Check compute. Are your GPUs starved? Are you hitting a PCI bottleneck? Step 2. If compute is fine, inspect serving. Are you failing to batch requests efficiently? Is your QPS bottlenecked at the server runtime? Step 3. Check orchestration. Is your agent stuck in some endless tool routing loop, just calling the same API over and over again? You check all of this before you ever even touch the model layer. Operating systematically like this literally saves hours of downtime.
Using this framework forces a massive shift in your engineering culture. So I'll leave you with this final provocative thought to take into your next incident response call. When your AI system inevitably goes down, and it will, which specific layer of the stack are you going to investigate first? By establishing the shared language from compute all the way up to experience, you're empowering your teams to build faster, diagnose a whole lot smarter, and scale with real confidence. Thanks for joining this explainer briefing, and good luck out there.